Hi dear students, today we are going to see the first chapter of physics, which is called physical world and units and dimensions. Now here onwards your journey to physics are starting. Whatever you have learned in 8th, 9th, 10th standard, it's completely different will be here. Different in the sense little more depth concepts you are going to learn, and so that you might feel like the next 2 years will be difficult, but it is very simple, like the way in which how you are studying. So that is important. It's not like just a mug up how the whole physics will not help you understand the concept from first class till the last classes, so that you will have a clear picture and you can able to answer most of the numerical questions which is asking from the session. So I'll completely stick on to the NCERT textbook. So NCERT textbook will have the first chapter is called physical world and the second chapter is called units and dimension. Physical world, it's just what is physics and what are the forces and some basic information. There are mostly I don't see questions are asking from these chapters for the Neet and JEE entrance examinations. You can just read this textbook only for the first chapter called physical world. Okay, there are questions will not come mostly from the chapter, so you can just go through the chapter. It's what can say, it's a very basic theoretical concept, just some theory. You just read 1 or 2 times and leave it. That's all. Here now we'll go to the second chapter, that is called normally we'll call physical world, units and dimensions together. Physical world, nothing will be there, so some simplest concept will be there which you can just read through your NCERT textbook first chapter. So please read 1 or 2 times and leave it out. We'll go to this second lesson, which is actually called units and dimensions. It is actually a combinations with the first lessons, units and dimensions. So write on the first heading called dimension, D-I-M, dimension. So many things, if I am speaking here, you may feel it as a new terms. Actually all these terms you will learn in first year also, second year also. Normally if you are taking the classes for the students who are preparing for NEET or JEE entrance examination after +2 repeaters batches, normally I will take this chapter at the end of all the chapter, because this chapter will contains many formulas, many equations which are coming from your second year, might be from your first year. But here we will see some overview, and on the run also we will get to know what are the other formulas. So just take a note whatever I am writing here, whatever you are listening and what you understand, write it your own words. We are not writing any like many theories, but we are understanding the concept. That is the main highlight, how you are understanding the things. Okay, so just write down the notes along with me so that it will be smooth. So dimension means in physics we know there are different units will be here. For example, I will say, I am saying like 2 liters of petrol. 2 is a number. Okay, so that is called magnitude. Liter is called a unit. I'll write one example will be here. 2 liters. Here the number 2 is called magnitude. Number 2 is called magnitude and the liters is called unit. I'll take another example. 2 kilogram of sugar. So here you know like 2 is called what? 2 is called similar to this one. 2 is called magnitude and kilogram is called unit. So kilogram is called unit and 2 is called magnitude. Okay, so the same thing, a physical quantity. Physical means which we can experience it, we can see it, that is called physically present. Okay, now you are seeing my video, but I am physically present on you are physically presented or I am physically presented to you. No, you cannot see it in me physically, but you are seeing my video. So when you are seeing my video, you cannot say I am a physical object, but when you are seeing me directly, you can see me, I am a physical object. So every physical object whatever you have seen will have a magnitude and a unit. So this dimension is a quantity which is related with called unit. Okay, so there are basic dimensional quantities are available. So what are the basic dimensional quantities? Basic dimensional quantity. So before I am going to say basic dimensional quantity, means dimensional is a term which we are used to represent various units. What are the various units? Kilogram will be there, liters will be there, different units will be there. So the dimension is a set of parameters which we are used to represent certain other units. Okay, I will take some basic dimensional parameters. So basic dimensional quantities, or I can say basic dimensional parameters. So these basic dimensional parameters, what are the basic dimensional parameters? Mass m, okay, length l, and time t, mlt, time. Another basic parameter sometimes called theta. Theta is a dimension formula for temperature, Kelvin, temperature, heat. So normally we are representing temperature in terms of a unit called Kelvin. So the corresponding parameter is called theta. And we have one more thing is there, that is called A. A is called ampere. Ampere is the unit of current. At least in the 8th and 9th standard also you have learned about, right? Ampere is a current. So for all the units we are going to represent MLT theta A format. MLT theta A format. Let's take one example so that it will be more clear to you now. Okay, you have heard about the term called momentum in 10th standard, right? You are heard about the term called momentum. How the momentum is representing P, a letter called P, momentum is representing. What is the equation of momentum? You know, equation of momentum, P is equal to mv. You have learned this in 10th standard, right? Yes. So m into v, mass into velocity, momentum, P equal to mass into velocity. Now we know the unit of this one. First we are going to write the unit of this one. What is the unit of mass? Mass in the unit kilogram. What is the unit of velocity? Velocity is the displacement divided by time. So displacement is meter divided by time. Time means second. So kilogram meter per second is the unit of momentum. Correct. This is a unit. Now this unit we are going to convert it into what called dimensional parameters or dimensional quantity. So kilogram in the corresponding dimension formula is what will be here? M, mass. So the corresponding dimension formula I am writing will be here M. Meter is what? Distance corresponding to distance, what is available? Mass, length, time, temperature and current. So length means we'll say 1 meter, 2 meter, 3 meter, right? So here meter is related with what called length. So ml. Okay, then here per, which means divided by. So ml divided by second in the corresponding parameter is called what? Called time. So ml by t. This we can written as what is the meaning of this equation? M power 1, L power 1 and in denominator t power 1. In the denominator term, if you are taking to numerator, how it should come? M, L, t power, yes, tell me, t power minus 1, ml t power minus 1. So this is the dimensional formula or dimensional quantity of momentum. Now you already get to know how the questions will ask, right? They will tell you one parameter. In the Neet or JE entrance examination, question is very simple. They will tell you one parameter called momentum. And which of the following is the correct dimensional quantity or dimensional formula? This is dimensional formula or dimensional quantity of momentum. So same way the questions will come. They will ask you, instead of momentum, they will ask you some other quantity. I'll tell you one example. Force, you have learned in schools also, right? Force. What is the dimension formula for force? We'll take it as a next example. So we are writing force, next point. Okay, so you can see star things I am writing. All the star points should be there in your notebook also. Okay, so what is called force? Force, you know, it is representing using a letter called F. F is equal to ma. Okay, we know the unit kilogram. Okay, so kilogram is a unit of mass, and what is the unit of acceleration? Meter per second square. So kilogram meter per second square is a unit of accelerations. Now this unit we are converting into what called a dimension formula. You don't want to really write a unit, because if you are learning like 2 to 3 classes after, you will directly write, okay, m means mass, then you will write m. Acceleration is meter per second square. Can you tell me what is the dimension parameter corresponding to meter? Meter means length means L divided by what is second square? Second square means time, second means time, so T will be here, so T here square. Now how the formula will be changing? M L, this denominator will go to numerator, so T power minus 2. So this is the dimension formula for force. So there are lot of physical quantities will be there, physical equations are there, as like momentum, as like force. Okay, so all this quantity you have a something called a dimension formula. So in entrance examinations, they will give you one parameter and they will ask you which of the following is the correct representation of the dimension formula. This way the questions will be coming from this topic alone. Okay, now we'll take some parameters one by one. Have a list of parameters, we'll take one by one and we'll try to derive the dimension formula for that parameter. Okay, so we have a lot of equations will be there. So whatever I am whatever I'm going to tell you here is not limited to that. It's more number of parameters will be there. So whatever are commonly asking things I am listing and we are discussing in the continuation of this one. Okay, so we'll go here, we'll clean this board. So just note down these points in case you have not noticed so far. Okay, we are going to derive some formula which are based on this different equations in the sense different physical equations of this one. Okay, so momentum we know and force also we know, and we are going to derive the next set of dimension formula for rest of the parameters. Okay, so we are going to do this. Okay, so we have next parameter, next things I am going to write is called pressure. Have you heard about pressure, right? P, I am writing it as P. Pressure is equal to force divided by area. What is the dimension formula for force? Or you can take it as an equation format. In order to derive it in an easy way, you can change this into a formula wise. If you change this into a formula wise, then things will be getting easier for you. So F is, we know on one equation. First we will formulate the equations, then you can write the dimension formula. A is called area. Pressure equal to force divided by area. This is the equation of pressure. Force I am replaced with any non-equations what I have. So I know this equation, F is equal to ma. Now I am deriving m in the unit is m in the corresponding dimension formula is what? M means mass. Acceleration meter per second square. So meter dimension formula L per second square. So per second square dimension formula T square. Okay, so numerator is over, come to the denominator. Here it is called area. Area, how normally we'll say area? Length will say in terms of meter. Area we are saying in terms of what called area? We are saying in terms of meter square. Meter square means meter is L, so meter square is L square. We are just rearranging this equations. ml denominator la T square L square there. This will come to denominator, right? Now we'll take into numerator. Here L in the power 1, L in the power 2. So 1 L will get cancelled in this equation. So what is there? Extra 1 L will be here, right? This is taken to numerator. M L power minus 1 T power minus 2. This is the dimension formula of pressure. Okay? Okay. We'll go to derive the next dimension formula. Next dimension formula is called for work. And this is also same as called energy. So work and energy. What is the equation of work? This is also you have learned in school, right? What is called work? W. W, work. Both are same dimension formula. Energy. Energy name work means it's the ability to do something. So if I want to do some job, I have to need some energy, right? Morning I'm going to do some work. So morning if I take breakfast, I will get the energy via food. Then I can do a work. So it is work is equal to nothing called energy. So W is equal to what called force into displacement. This is the formula for work. If you don't know the formula, if you are not remembering the formula, please write it on your notebook. Work equal to F into S, which means force into displacement. What is the dimension formula for force? We know MA. We already written will be here, right? So it is ml by T square. It's a dimension formula for F and multiplied with S. S is the displacement or distance traveled. So what is the value of this displacement? Displacement means a distance, length in the formula L. So how will the formula will come? L is multiplied with this L, ml square, denominator T square and so denominator T square will be written will be here. Next, if you are rearranging the formula, what will happen? The denominator is going to numerator. So the formula changes to ml square T power minus 2. Okay, numerator, if you are taking one parameter into denominator, this L if you are taking to denominator, then L square become L raised to minus 2 now. If you are taking from denominator to numerator, so plus become minus will be there. This is just a simple mathematics, right? Simple mathematical formula. If you are taking something from denominator to numerator, the sign will be changes from plus to minus. If it is from plus, and if it is already minus, so minus to plus, the formula will be getting changes. So pressure will be there, work will be there, and we already learned about a momentum, and we already learned about other parameters called force also. So totally now we have 4 parameters are available, and just note down these points. So this is not limited to this one. We also have another set of formulas will be there. Here work is something called energy. Okay, so work is equal to energy. What are the different types of energies you know? You know it's called kinetic energy, you know it is called potential energy. So any type of energy will have the same formula, same dimension formula of work. Okay, so we'll go to the next physical equation, and we are going to derive the dimension formula for that physical equations. Okay, the next physical equations is called surface tension. It's called surface tension. Surface tension is the next physical equation. So what is the formula for surface tension? Normally we are representing using called capital T. So surface tension, the formula force per length. This is the formula. If you don't know the formula, no worries. In the next classes, in both in first year and second year, you all are going to learn all the formulas. What are the formulas I am going to tell you. So no worries, no tensions. Just now understand surface tension is it's an equation. It's a physical parameter whose formula is force per length. Okay, what is the dimension formula for force? ml divided by T square divided by length L. Correct. So mass into acceleration. So ml per T square divided by L. L and L will get cancelled. What is the dimension formula? M divided by T square. So how we can write mt raised to minus 2. So this mt raised to minus 2 is the dimension formula for surface tension. Another term, this is there are less chances you have heard about this term, is called moment of inertia. This also we are going to learn in first year in one chapter called rotational motion. The rotational motion chapter you are going to learn this things. Okay, so what is called a moment of inertia? Moment of inertia normally representing m dot ia, or we can also representing using a letter called ia. Okay, so I am using will be here I. Moment of inertia general equations will be equal to mr square. Mr square. M is called mass, r is the radial distance, or simply you can say distance. As of now, we will learn this more about in later chapters. So m into r square. So m in the unit mass, mass in the unit capital M, unit dimension formula. Here distance r is called distance, length. Upper r square means length in the square. How will come? L square. So ml square is a dimension formula for moment of inertia. Okay, so couple of things we have learned. What are the physical quantities? What are the for all the physical equations, whatever you are going to learn will be here. Will have some dimension formulas will be there. Okay, so right on the next point. Next one is called angle. Angle. Normally, how will say angle? Angle will say some theta equal to. Normally, we are representing using called theta, right? Theta. Theta is called angle. Do not confuse this theta. Previously, I told it is used to represent what called temperature. So here it is called angle. Two meanings are there. That's all. No confusions. So angle equal to theta. So what is mean by theta? Angle theta. Theta representing if I have a triangle, something like this one. So this 30 degree I am representing 30. So 30 degree means it has any unit? No, only it has number. So no unit means no dimension. So this is an example for a dimensionless quantity. This is dimensionless. Dimensionless means this has no dimensions at all. That is the meaning of this one. Similarly, in entrance examination, they will also ask you, just to confuse you, it's something called a solid angle. This is also related to angle only, but in another way. So this will also learn when we go into the subsequent chapter. As of now, you can understand this is something like an angle, and this is also a dimensionless quantity. So two dimensionless quantity we have learned, angle and a solid angle. There are one more dimensionless quantities will be there. Anybody remembering what is called a dimensionless quantity? Dimensionless quantity has no dimensional parameters, which means there is no m, there is no l, there is no t, no theta, no ampere, nothing. So next, there is one more dimensionless quantities are there, which are very commonly asking for entrance examinations. These are normally coming for your final entrance examinations, and we'll see. That parameter is called a strain. You will learn in your first year itself, but after a few months, that is called a strain. Okay, strain. Strain the general equations. I am writing the general equation of strain. Change in length divided by original length. This is the formula for strain. Change in length divided by original length. So change in length divided by original length. Change in length. So this is nothing but a length. Correct? Change in length means a difference in length, or I can say from 10 meter to 13 meter. So how much it is a change? 3 meter. So it is a meter. So physical unit dimension is L in the numerator. Denominator is also original length. So it is L itself. So L and L get cancelled. There is no dimension formula. So this is also an example for a dimensionless quantity. So like angle and solid angle, this is also an example of a dimensionless quantity. This is a very commonly asking question. And we'll see next parameter. The next parameter is called torque. This you might be heard about the term called torque. Torque normally we are representing called toe, like this toe. Okay, it is like we are just representing the letter J in a reverse way. So it's called torque. So what is the general formula for torque? Torque is equal to force into distance. Force into perpendicular distance. You have learned this formula somewhere also, right? Where you have learned instead of this distance, I know you have learned one formula called F into S. Instead of this torque, what you will write? You will write W. You remember this formula, right? Just before 10 minutes, I spoke about this one. So W equal to Fs, force into displacement. Same way, torque is equal to force into distance. We will learn more about in torque in later work power energy chapter. You will learn about it. So torque is equal to force into distance. Here it is called force into distance, here it is called force into S. So this will also have the same dimension formula of work, which is also same as something called energy. So all will have the same dimension formula. So the dimension formula for torque is same as work, which is same as energy. This dimension formula already we have written, right? We know the force dimension formula, ml t raised to minus 2 into multiplied with length. So the torque dimension formula, ml square t power minus 2. Okay, you can derive. This is same as like work, no difference. Instead of S, we are representing something called D. D is also called distance, S is also called distance. You can use any parameter, but idea will be the same. D and S are used in different books in a different context, but D is equal to S, both are equal to distance only. So dimension formula of torque is this. Okay, so it's called energy. So all the things we have learned. Now there are few things which are normally coming, like what we can say, like there are some other quantities which are also called dimensionless quantity, similar to your what I can say, your solid angle, ankle and strain, and there are other quantities are there. And one other example, and I am just keeping will be here strain, so that we know strain is a dimensionless quantity. Strain will have no dimension. And similarly we have another dimensionless quantity is called refractive index. We will learn in one chapter called optics. You have learned about light, right, in your schools. So refractive index called light. The formula for refractive index is C divided by V. C is called speed of light. This is also velocity. This is also velocity. Velocity by velocity cancel. What is the dimension formula for velocity? We simply write velocity is equal to displacement by time, S by T. You have learned this in school, right? So what is displacement? L divided by T. This we can write as LT power minus 1. So this LT power minus 1 will come on the numerator, LT power minus 1. Denominator also what will be the formula? Same, LT power minus 1. Here you don't want to confuse. Here refractive index is C by V. C is called velocity of light in a normal air medium or in free space. This is velocity. This is V is also called velocity. C is also called velocity. But velocity of a light ray, it happen in a different medium. This may be velocity in a water medium. This is a velocity in an air medium. This is a velocity in a kerosene medium, and this is a velocity in air medium. So it is just a medium is changing, but numerator and denominator both are actually what called velocity. So velocity by velocity means both will get cancelled, right? Here L cancels and T cancel, and what is your dimension formula? Everything got cancelled. So you have no dimension formula for this parameters. Okay, so we have one more parameter is called, this is called mechanical advantage. Okay, what is the meaning of the term called mechanical? Have you heard about the term called mechanical? Mechanical advantages, you will learn this in future also. Mechanical advantages indicate load divided by effort. Okay, load means weight, nothing. Effort means also called weight. So how much is the load will be given divided by how much will be this called effort. So load by effort. So load, it's something called mg. Okay, so this is mg means mass into gravity. So for mechanical advantages, we have written load by effort. Load I have written mg and ma. So load is nothing called weight, which is equal to mg. We know weight, right? Weight is terms of mg. Weight and mass is different. Mass is representing only in terms called m, but weight means it is called mg divided by effort. Effort means force. Force is called ma. So m and m get cancelled. G is acceleration due to gravity. A is called the normal acceleration. Both will get cancelled. So this is also an example of a dimensionless quantity. Hope you understood the basics things which is related with this dimension.